Alright, welcome to Packet Tracer Activity 132, Investigating Failure Domains. So we're looking at three different types of topology here, and we're going to see what happens when you have a failure and how they recover from that. So for the first one we're going to look at is the partial mesh topology. So you can see everything's green, the network's converged. It has one that's orange. That's going to be shut down due to something like Rapid Spanning Tree Protocol, which has shut that interface down to avoid a switching loop. So you can see if we're going to observe some traffic. So if we get traffic from PM3B, we'll send it to PM4B, and we'll watch that. So you can see, there you go, it's making its way up and around and back down. So you can see it follows the green lights all the way up and down. So then, once we do that, we're going to introduce some point of failure in our partial mesh topology. So we are going to take this link out between PM2 and PM4, which our traffic was just moving on. So we'll wait a little bit for this link to converge. Alright. So if we watch that traffic this time, it goes up there, and there's nothing up there, so then it looks again and heads to PM4 and down to PM4B and back. So you can see with a partial mesh topology, if one link goes down, it will reactivate the one that's dead, and so the whole network is still all hooked up. So let's go over to our star topology, and you can see everything's green. Every link is lit. So let's observe some traffic from S2A to S4B. So it goes down into the middle one, down into this bottom one, and over here, and then back up. So you can see where the traffic's going there. So let's introduce some failure on the star topology. We will delete the trunk link between star 1 and star 2. So star 1 is the middle one, this is star 2. So we don't have to wait for anything to converge. We've essentially just cut ties off with our middle switch here. And if we run this one, we'll see it tries to send the traffic, but there's nowhere to go. It goes to this other user. That's not the destination, and it has nowhere else to go. So essentially this group right here is cut off from the network. So that's the star topology. So let's look at the full mesh. Alright, so the full mesh has 1, 2, 3 links that are shut down to prevent switching loops. You can see there's a lot more lines than the partial mesh. It gives it that extra layer of redundancy. So we want to look at traffic from FM1A to FM3B. Okay, so that's coming down here, going across, up here and back. You can see that better with this envelope, the path that it's taking. So we want to we want to put some failure into this domain. So what we are going to do is delete the trunk link between FM2 and FM3. So here's 2 and here's 3. So this was, if you recall, the path that was going on. And we just have to wait for something to converge here. Alright, so it looks like we've got a link up right there. Oops. Let's try this again. So FM1A to FM3B. And there you see it's gone around to get to it. So you see instead of coming across here, that switches, this interface is open, so it can move along there. So the traffic, everything's still connected. And technically you could still lose this link and everything would still be connected. And you could lose this link, everything would still be connected. So a lot of points of failure would not affect that network connectivity. So when you're looking at the topologies, the star topology is different because there's really no recovery from that. It's got one line connecting it to everything else. Each switch has one line going to this main switch connecting it to everything else, so if that line goes down, then they're off the network. And so as soon as that line went down, these hosts right here have no access to the network. So it's important to put some redundancy in your network design just to make sure there's you can recover and still access crucial network functions if you have a cable go down. So thank you very much for watching. This has been Packet Tracer 132. Have a good day.